Well, hi everyone. This video deals with the arc length and area of sectors. So the arc length around the circle. So when we're talking about arc length, we may be talking about something like how far is it from this point to this point along the circle? What is that distance, that curved distance there? That's arc length. The area of a sector, let's say we just take this sector here. What is the area that this sector is covering? So those are the kind of things we're doing. We have a couple of formulas. This formula, S, is for arc length. You know, R is for radius. Theta is the angle, the central angle in radians. Now, I don't know if I've made this, I say remember, and I'm not sure we talked about this too much, but the arc length over the radius gives us the number of radians for measuring an angle. Theta equals the arc length over the radius. So if I multiply both sides here by r, I can get arc length by itself, and that's the S, and then that equals r times theta. So let's do an example. A circle has a radius of 27 inches. So there's my circle. It has a radius of 27 inches. Okay. Find the length of the arc intercepted by a central angle of 160 degrees. Well, if you'll recall, there's 90. This is 180. So it would be like right around here. We have 160 degrees here. Okay, the thing we got to be careful of. So I want to know this distance right here, from this point to this point. That arc length. We have this simple formula. The only problem we've got is it only works if the central angle is given in radians. So we need 160 degrees converted to radians. And 160 degrees times pi over 180 degrees will do that for us, because the degrees will cancel out. Let's see. Let's divide by 10. Let's divide by 2. That's 8/9. So S, the arc length, is going to be, well, let me finish my thought here, is 8 pi over 9 radians here. And S is going to be the radius, which is 27 feet, 27 inches, not feet, 27 inches times 8 pi over 9 radians. When I'm done, I'm going to have a length in inches. So 27, I'm going to just cross out the radian measure there. I'm going to divide this by 9 and this by 9, and 3 times 8, so I got 24 pi inches. Now if you want a more practical answer, you're going to take 24, that's not 24, 24 times pi. Pi is that second there. And I get 75.398. This is a more practical answer. This is the exact. This is a practical approximation. Okay, just know what we're asking for in the problem. All right. And now, that is arc length, finding the distance along the circle. Now, the area of a sector, we have this formula. Area is 1/2 r squared theta. Theta, again, is in radians. And if I have a sprinkler, I'm going to draw. Okay, you got your sprinkler here. It rotates through an angle of 80 degrees. So let's say it sprays that direction to 80 degrees. There's 90, so like this. Here is the water spray here. This is 80 degrees. This is 40 feet. So it sprays at 40 feet out. What is the area being covered here? How many square feet is being covered here? So we're going to take 1/2 times the radius, which is 40 feet, times, okay, once again, I'm going to have to convert, and I didn't do that yet, 80 degrees times pi over 360 degrees. And the degrees cancel. I'll divide by 10. 8, let's divide by 4, so that's 2, and that's 9. So I'm multiplying by 2 pi over 9 radians. And half of, well, you got to square the 40. So that's 1/2 times 1,600, and that's feet squared, times 2 pi over 9. Now the 2 and a half are going to cancel. So in the exact answer, I'd have 1,600 pi over 9 square feet. And the practical answer, well, I'm going to actually take 1,600 pi and then divide that by 9 and get 558.505 square feet. Okay, little simplification. I had this half out here, and I had the 2 up here. The 2 up here and the 2 down here do cancel out, in case I didn't explain that. All right, you guys take care. I'll see you tomorrow morning.